It is intuitive to understand how sensory information gets to the brain and how motor information can travel to muscles. Together, these two systems allow us to detect and respond to the world around us. But how do we engage with that world? How do we determine what is important? How do we fall in love? These higher cortical functions involve the complex interplay between neurotransmitters and hormones throughout the entire nervous system. There are two major anatomical substrates that influence these behaviors: the limbic system and the hypothalamus. Today, we're going to take a closer look at these structures that support many higher cortical functions. The hypothalamus is a very small structure, but it is absolutely critical for life. It allows us to respond to both the internal and external environment and to maintain homeostasis. The limbic system is important for learning and memory and all emotional aspects of behavior. Importantly, limbic and hypothalamic structures are interconnected with each other. Let's begin with an anatomical overview of the hypothalamus. In this mid-sagittal section, you can delineate the hypothalamus from the thalamus via the hypothalamic sulcus. Anteriorly, the hypothalamus extends to the anterior commissure and the optic chiasm. Inferiorly, it includes the mammillary bodies and extends to the infundibular stalk, where it communicates with the pituitary gland. This is a coronal section through the brain. This is the third ventricle. You can identify the thalamus on either side of the third ventricle. And underneath the thalamus is the hypothalamus. It extends laterally to these descending fiber bundles, which are part of the internal capsule. The hypothalamus is structurally part of the diencephalon, but it functions as part of the limbic system through reciprocal connections. It helps to maintain homeostasis in the entire body through influences on the endocrine system and, importantly, through its primary influence on both the sympathetic and parasympathetic systems. The limbic system is extremely old from an evolutionary perspective. In its connections, it is interposed between the hypothalamus and the neocortex, providing a bridge between endocrine, visceral, emotional, and voluntary responses to the environment. We now know that widespread areas of the central nervous system are part of this processing. However, here we will focus on the core limbic structures. These structures include deep forebrain nuclei and cortical areas. The key cortical area is the limbic lobe. It is not a true lobe, rather it spans the frontal, parietal, and temporal lobes. It comprises a ring of cortex on the medial surface of the brain, the cingulate gyrus, and the parahippocampal gyrus. This anterior swelling of the parahippocampal gyrus is the uncus. We're now going to have a look at the deep structures of the limbic system, the hippocampus and the amygdala. The hippocampus is primarily involved in memory, and the amygdala is primarily responsible for emotional processing. In this specimen, we have opened the lateral ventricle to show you the hippocampus as it lies in the floor of the inferior horn. This bulge here is the hippocampus. Towards the posterior end, you can see fibers emerging that will form the fornix and will swing over the thalamus to reach the mammillary bodies of the hypothalamus. In this specimen, we have approached the hippocampus from a medial approach. We have taken away part of the temporal cortex here. The lateral ventricle is right here. And lying in the floor of the lateral ventricle is the hippocampus. This unusual view of the hippocampus shows the underside of this structure and exemplifies the increased surface area achieved through extensive folding. Here's the outflow from the hippocampus, the fornix. These fibers swing around the thalamus and come down here as the columns of the fornix, just posterior to the anterior commissure. The columns of the fornix will project down to the mammillary bodies. The mammillothalamic tract is going to connect the mammillary bodies with the anterior nucleus and the dorsomedial nucleus of the thalamus. From the thalamus, the information travels to the limbic lobe. This is the classic Papez circuit involved in learning, memory, and emotion. We now know that many other structures are involved in this circuit, including the amygdala. The amygdala is located in the roof of the inferior horn of the lateral ventricle, directly underneath the uncus. Here is the uncus. The uncus is the anterior extension of the parahippocampal gyrus. It's easily identifiable through its hook-like appearance. Directly underneath the uncus lies the amygdala. Let's take a look at a cross-section through this area. This is a coronal section through the forebrain. This is corpus callosum. That's the anterior horn of the lateral ventricle. And here's the inferior horn of the lateral ventricle. And here in the floor of the inferior horn, you can see the hippocampus, right here. Its different layers of neurons give it that striped appearance. When we turn this section around, we're now more anterior, and we can see the amygdala. It lies superior and anterior to the hippocampus. This stretch of cortex here is the uncus. The amygdala is a key structure in the expression of emotion, emotional memory, and basic drives. Let's get oriented to this diagram. This is the lateral ventricle, this is the anterior horn, the posterior horn, and this here is the inferior horn, which lies deep within the temporal lobe. This here is the thalamus, this is the hippocampus and the fornix, and this here is the hypothalamus with the mammillary body. Let's trace the Papez circuit. This circuit is the bridge between emotional, endocrine, visceral, and voluntary responses to the environment. From the hippocampus, a fiber bundle emerges. This is the fornix. It swings around the thalamus to converge right here behind the anterior commissure as the columns of the fornix. The columns of the fornix project to the mammillary body. From the mammillary body, the mammillothalamic tract projects to the anterior and dorsomedial nucleus of the thalamus. Modern neuroscience has established a link between the amygdala and the hypothalamus as well. This is an important connection for fear responses and saliency filtering. An additional layer of integration happens within the limbic lobe. This is the basic network of connections that allows us to engage with our environment, determine what's important, and fall in love.